Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were doing our pattern wise rising brain sheet, and in this we were doing the prefix sum pattern, and inside it today we will do the third question, which is product of array except itself. So let's see the problem statement. It says we will be given an integer array nums and we have to return an array answer where each answer of I will contain the product of all elements except itself. So here we will be given an integer of arrays, and if you will see the product of, so product means 2 into 3 into 4, and that is nothing but 24, correct? So we have to save the answer here 24 without using this. So we have to exclude this. Now for this first index value, we have to multiply all left side and all right side values. So if you multiply, it will become 3 into 4 into 1, which is 12, and hence we can see here 12 is our answer. Okay, and remember the question says we have to do this without using any division operator. Okay, why this division operator? Because you might think ki why not to do the product of all subarrays elements, and then whenever at whatever index we want to calculate without, we will divide this. That we are not supposed to use. Okay. Now let's see the constraint. Constraint says the array length will be from 2 to 10 power 5. Okay, 10 power 5. Again, n square we cannot use because n square will become 10 power 10, and you know that beyond 10 power 8 it might give us TLE. So hence we have to optimize here. How we will optimize that we will see later, but let's see the brute force approach in this case. And if you will see the nums of I value, see that can be negative also. So it ranges from minus 30 to plus 30. Okay, now we are aware of the problem statement. The question says we will be given an integer array first, and we have to store at this index in our resultant array, we have to store the product of leftover elements except this index value, and that is nothing but 3 cross 4 cross 5, that is 60, correct? And here we are not allowed to use a division operator. Okay, so without division operator, can you think of any approach like brute force approach? Yes, we can. What will be the brute force approach? Ki run the I loop from the 0 index, correct? And for whatever index we want to store the answer. Suppose for 0 index I want to store the answer. So whenever my I hits the same number, don't multiply that, correct? And in that case, if I is matching, so move this, 3 is not matching, multiply this. So it will become 3. Now 4, 3 into 4, 12. Now 5, so 5 into 12, 60. And hence at this position, we can put the answer. But at what position? That also we have to keep a track, correct? So means I am saying let's put a left variable here and let's rename this as right variable. So for every left variable, right variable, we can start from 0 index to last, except when right matches with left. Why I said this? If you think ki why not to start this right pointer from the same position, okay, that is okay. So if you are starting your right pointer from the same pointer, means whenever you are matching left right, that we will not include, and then you will do right plus plus and you will include this, correct? But remember, in this we need the left product also, no? That too we will miss. So hence this right pointer will always start from 0 till last, and whenever left and right overlaps each other, means having the same value, that value we will not multiply in our product variable, and hence we will not put in our answer also. Okay, so now the same idea we can write in the code format as well. How? Let's see. So I am saying first, to store your answer, you have to initialize your resultant array of same size, correct? So it will be also of 4 size, and we will initialize with 0. Can we initialize with 0? Yes, we can. Because even though the number was negative, so when we will multiply it, whatever it will become positive or negative, we are going to override now. Whenever we have to store the maximum or minimum, then we have to take care of these value with what we are initializing. But anyhow, we are going to override this, so it does not matter. Now I said let's start a for loop for what? For left pointer from 0 to left pointer till nums dot length, correct? And left plus plus. We will do this, and inside it what we want? Inside it I want to calculate the product variable. So hence the product will start with 1, and now I want to initialize my right pointer, and right pointer will start from 0 only, and it will go till nums dot length. Means I am allowing this right pointer to go in the entire array. Okay, and whenever my right pointer hits the same left pointer, that number I will not include in the product. So how I can write? Ki if right is equal to left, then we will simply continue, correct? Otherwise what we will do? In the product we will multiply our what? Nums of right pointer variable, and when we will come out of this for loop, I can say ki I have product ready to be stored where? In the result of left pointer. So after coming outside we can say ki result of left pointer, I want to put this product variable as an answer, correct? And after coming out of both of these for loop, we can simply return our result, correct? Our result. And if you will see the time complexity here, the very first for loop is running for n times and second for loop is also running for n times. For every left pointer, our pointer is running from 0 to n, correct? So hence total time complexity of O of n square, and you saw the constraint was 10 power 5. So n square will become 10 power 10, and beyond 10 power 8, you know that it might give you TLE. For sure 10 power 10 will give you TLE. So we need to optimize here, correct? So how to optimize? You know, whenever we talk about optimization, 4 different patterns of arrays comes to our mind. What are those 4 patterns? First is 2 pointers, second was sliding window, third prefix sum, and fourth is cadence. You know, we apply this 2 pointer only when we take care of or we consider only these 2 numbers and nothing in between. Okay, so we cannot use this because you know ki suppose for this, if we want to calculate the answer, we want everything in between. Okay, sliding window we use when we have to give the multiplication, summation, division, everything, but in a continuous window, not in a subsequence. And here you can see ki we are leaving in between and we are calculating the left and right products, correct? So hence no 2 pointer, no sliding window. Now let's talk about prefix sum. Prefix sum is something ki we calculate, like either summation or product, whatever, but we calculate and then we will use it for multiple queries. Okay, so here we can think of it. Now talking about cadence we always use to calculate our maximum answer when negative number is a part of it, but for maximum summation and not for product. So hence we can ignore this cadence also, and here we will go with the prefix sum. Now why we consider this in the prefix sum problem? This is not exactly prefix sum, but it somehow resonates with the idea of prefix sum. How? Let's see. So we want the product of all numbers for this index except itself, correct? Yes. So what prefix idea we will apply here? Let's start from the left side. Okay, and then we will do for the right side. So for 2, what do you think? What should be the product from the left side? Obviously 1. If nothing is there, obviously 1, correct? So we will say only 1. Now next time, suppose for this 3, what will be the product of all numbers towards left side? What will be that? That is nothing but whatever you have stored in the result variable multiplied by that number. Why I am saying this? Why I am saying this result variable? Because if you remember, for this 2, you have saved your answer here, and saved your answer means whatever towards the left side. And if you will multiply this whatever towards the left side and this 2 number, then don't you think that will become the left product of 3? Yes. So that is why I am saying for every number means result of I. What we want? What we want? We want nums of I minus 1, means suppose I is here, okay, I is here, and we want to calculate the answer for this 3, okay. So how can we do that? That is nums of I minus 1, obviously, and what? Result of I minus 1 also. What? Result of I minus 1. Yes. So what will be the product? 2 multiplied by 1, that is 2 only. So we will store this 2, okay. Now let's move our I pointer ahead. So now it will go to 4. Now what do you think? Nums of I minus 1, 3, and resultant of I minus 1, because resultant of I minus 1 is having nothing but product till here, and when we will multiply this 3 into that, then that will become left product of 4, correct. So hence that will be nothing but 3 multiplied by 2, it will become 6. Yes. And if you will see here, for 4, what is the left product value? That is 6 only. Now we will move our I pointer ahead for 5. And now say, for 5, what is the left product? That is nothing but 4 multiplied by 2 multiplied by 3. So we are not doing it again and again. That is why we have stored our previous answer here, and we are reusing this previous answer calculated in the result of I minus 1 and what? Nums of I minus 1. So basically that is why we are saying that this is somehow resonating with prefix sum idea. So we'll multiply this 6 and 4 and it will become 24, and here we will save the 24 as an answer For what? For 5. So now can I say this is my final answer? No, it is not. Because for every number, for 3, whatever answer you have here, that actually tells only the left product. We have not calculated the right product till now. Okay, so means I will again run a for loop, but now this time from the right index. Okay, now you say when I'm standing at 5, what will be the right product from right side? You tell. What will be the right product? That is nothing but 1 only. Correct? 1. So don't you think for 5 what I want to store? I want to store the right product and the rightmost number, but in the array I don't have anything. So can I say for 5 I can simply store 1, like whatever is there I can simply multiply with this. Why I have to multiply? Because this is nothing but left product, and we have to multiply for every number. Left product I have stored here, and right product when I will multiply, so it will become right product and left product multiplication. Correct? So hence 5 is not included in that. Yes, I can say. Correct? So what I will do, for initially right product, for the last index it will be 1, and that I will multiply here. Correct? Yes. Now next time for this, what you want? The left product is obviously stored at the same index 6. Yes, at the same index. So whatever I index we are pointing here, remember in the left product we did I minus 1, but in this we are actually referencing the same index. So for 4, whatever is the left product at that index multiplied by right product. Now what is the right product here? Can we reuse this? Think. No. We cannot reuse this. Why? Because this is actually product of every left number and right number for 5. So we cannot use this. No. So for right product, we will use a variable. What variable? So I am saying use a right variable. Right product. So initially it was 1. So for 5, we have multiplied this number and this right product. So it has become 24 only. Now, when my I pointer will go to 4, correct? My I pointer will go to 4. Now for 4, what I will do? Before moving this I pointer towards 4, I want to update my right product. So initially it was 1. Now I want to update with 5. And obviously it will be 5 only. Don't you think it will be 5? Yes, it will be. Correct? Yes. So now when I will be at 4, what I will do? I will multiply this 6 with what number? Do you think 24? No, 24 not. Then what number? Of course, right product. Correct? So this is 6 multiplied by 5, 30. And if you will see, except 4, the multiplication is 30 only. Yes. So now I can update this value from 6 to 30, and if you see, this is how our answer is getting updated also. Now next time, before moving our I behind, don't you think we should update this right product? Yes. Now how I will update? So basically, don't you think this 4 should be multiplied? Yes. So for the formula, I am saying my right product will always become multiply is equal to nums of right side. Okay. So earlier when it was 1, 5 got multiplied, and now when it is 5, 4 got multiplied, and it has become 20 now. So when I will be at 3, what answer I have for 3? Left product 2, and then it is multiplied with 20. So 20 multiplied by 2 will become 40, and hence here we will store 40 as an answer. And here's what's expected also. Now next time I can say I will move my I pointer behind, and before moving I want to multiply this 3 with my right product. So I will multiply, and now my product will become what? 60? Yes. And now when I will move this I pointer behind at 2. So what left product I have for 2? That is 1. So this one I want to multiply with 60, and hence it will become 60. Correct? And that's what expected also. Yes. So hence in this way we can reuse the prefix sum idea to store our final answer for the left product and right product. And you saw we use one for loop for left product calculation and another for loop from right side for right product calculation. So we use only 2 for loops, not in nested order, like order wise. So hence O of n plus n, O of 2n is the total time complexity, and as we have to return this array as a result, so space complexity will be O of n. So now this idea we can code here. So now what we will do, first we will calculate the length, that will be nums dot length, correct? Okay, now we want to return our resultant, and that will be of array. So int result is equal to new int, and what size? N only, correct? Now here if you will remember, in the resultant, the 0 index value for the left product, it will always store 1 only, no matter what value is present at 0 index, correct? Whether it is 2, whether it is 5 or anything, because here we want to save the left product for this number, and you know behind this there is nothing, so hence we have to initialize with 1. So that is why we will write result of 0 equal to 1. Correct? Yes. Now we want to run a for loop to store our left product. So for 0 index we have already calculated. So I want to initialize my I variable from 1. Correct? And I want to run this I till n and I plus plus. Okay. Now how we will save? In result of I, what I want to save? That is nothing but result of I minus 1. We just saw multiplied by nums of I minus 1. Correct? That's what we did. Now this loop will help us to save or store our left product in the entire resultant. Correct? Now we want to store the right product, and for that we want a variable called right prod, and that we will initialize with 1. Correct? And now again we want to run our for loop, suppose our variable starting from what? N minus 1. Correct? And go till where? Greater than equal to 0? Yes. And right plus plus and right minus minus. Correct? Because we are going from right to left. Yes. And inside it what we want to do? Now result of R. Now what result of R will store? Here if you will see, before we had 24, right? So for this the right product will be 1 only. So what I want? That right product to be multiplied with the same number, na? So hence here we will write result of R is equal to result of R multiplied by what? Right prod. Correct? And for next time I want my right prod to be updated. So what I will do? Right prod multiplied is equal to what? Nums of our current number. Correct? Yes. And after coming out of these both for loop, we can simply return our resultant answer here. Sorry, my bad. D. Prod spelling was wrong. So here you can see it has run, and now we can submit our code also. And now you can see it has been submitted. Correct? So this was our Java code, and now if you'll see here is your Python code if you're from Python background, and here is your C++ code if you're from C++ background. This question has repeatedly been asked in the interview, so I will definitely recommend you to do this. And with this we can go in our sheet and we can mark this as completed. So I hope you guys are doing with me, and if yes, then do let me know in the comment section by simply commenting done or understood or submitted, so that I'll get to know you guys are submitting with me also. So that's it. I hope you understood both brute force and optimize, and why only to apply the prefix sum idea here to store our pre-calculated value actually, so that we don't need to repeatedly do the same steps, and hence that reduces our time complexity as well. So that's it for the video, and if you guys are new to this channel and if you don't know about this rising brain sheet, I will definitely add the link of this sheet and my social media links in the description so that you can get and connect with me. That's it. I hope all these videos are helpful for you in your career or in your interview journey. If yes, then do subscribe and like the video, and you can share with your friends also if you think that will be helpful for them. And that's it for the video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.